Good morning. This is the second lesson for my Trig-Precalc class. This is lesson 4B. I decided to turn the fourth lesson into two lessons. I wanted to spend a little time on our third goal, which was discussing what the implications of functions that are inverse, what that actually implies about composition. So I just it's something that I need to put on your radar here. And you probably were taught this last year. It's just maybe it didn't click, but I just want to tell you this little story about this. Okay, so first of all, I'm going to talk about nice simple numbers, and then once we understand the behavior that I'm talking about with the nice simple numbers, we're going to look at what happened with composition and hopefully reach some conclusions here, or understand the conclusions. So the very first thing I want to talk about is that inverses are opposites. Right? And so 5 added to negative 5, these guys are additive opposites. If you add these together, you get 0. And 1/3 times 3, these are multiplicative opposites. And if you multiply these guys together, you get 1. So inverses are opposites, right? You add the opposite sign, you multiply the number, it's reciprocal, those are multiplication opposites. Now, it's important to understand that inverses, or as I just discussed, some opposite. Inverses lead to identities. Okay? And so these additive opposites led to 0, so 0 is the additive identity. And what that means is if I take any number and add 0 to it, I get the identical number back. So that's why 0 is called the additive identity. 1 is the result of these opposites multiplying together. So 1 is a multiplicative identity. So if I take any number I want and I multiply it by 1, I get that same number back. So 1 is the multiplicative identity, 0 is the additive identity. Now, in the lesson, I just said that f of x and f inverse of x are inverse. And we validated that by plugging in the inverse into the original and the original into the inverse, which we call composition. Composition is plugging one function into the other. And so, since these guys are inverses, like these guys were inverses or opposites, and these were identities, what that means is x must be the identity for when we plug in the function. So x is the plug-in identity. So what that means is if I plug in x into a function, I should get the exact same function back. Right? So here would be an example of my original function. And now what I'm going to do is I'm going to plug x into my original function. And if I plug x into my original function, you see that I get the exact same function back. These two guys are the same. And so this validates that x must be the identity for when we plug in the function. Right? X is the identity for composition. X is a function by itself. Right? F of x equals x is a function. So whenever I plug in x to a function, I should get the same thing back, which kind of makes actually a lot of sense. Because I'm replacing x with an x, I really didn't change anything. So what does this imply about composition? Well, it implies something that I don't think you guys are really, hopefully you're picking up on, is that composition is behaving like these operations. I've got opposites that lead to inverses, and these inverses lead to identities, and these identities mean that you get the same thing back. So operations have inverses, operations have identities. Therefore, we can conclude, what does this imply about composition? Well, it implies that composition must be an operation. It's an operation. And what does that mean about functions? Well, we can think of functions as numbers, and I mentioned it before. The further you guys go in mathematics, the more you're going to start to see it veer away from mathematics with the nice numbers, and it's going to start to become mathematics with the goofy looking. But again, here's what I believe to be a simple example of functions behaving like numbers, and which implies that they must be a structure like numbers. So behavior becomes very important, and it's because of similarity in behavior we can reach this conclusion that composition must be an operation. Well, that's all. I hope everyone's having a good day. Talk to you later. Bye-bye.